My name is Bhavan Shah, and today we'll talk about how you can leverage PX Backup version 2.1 to protect applications that are running on your Amazon EKS clusters, backed by an Amazon EFS backed storage class for dynamic volume provisioning. So this is a simple scenario where you might not be using Portworx as your storage layer for your EKS cluster, but you are leveraging EFS as the backend storage to provision or to dynamically provision your read-write many or shared volumes for your applications. For this demo, we have a simple example application called Jenkins, and it's running as a deployment which has its own pod, single replica, and it's dynamically provisioning a read-write many persistent volume that is hosted by EFS file system. We have a second cluster, which is a dedicated backup cluster, which is running PX backup on a Portworx storage cluster. And we are using this PX backup instance to protect the application, the Jenkins application that's running on the first cluster, save the snapshots in an S3 bucket, and restore the same application back to an EFS backed storage class. So this scenario is important for customers who are not yet using Portworx at the storage layer, but still want to leverage PX backup for Kubernetes backup and restore functionality for your EKS clusters that are either backed by EBS based block volumes or EFS based backed file volumes. So let's see all of this in action. We are logged into a jump host that has access to our Kubernetes cluster running Jenkins. Let's do a kubectl get all in the Jenkins EFS demo namespace. Here you can see the deployment, replica set, and pod along with the service object. We can also do a kubectl get PVC in the same namespace to look at the persistent volume called Jenkins home PVC that is provisioned using the EFS demo storage class. The EFS demo storage class uses efs.csi as the provisioner to provision read-write many volumes off of an EFS file system. So we are not using Portworx anywhere in the storage layer for this cluster. Okay, the reason we are using Jenkins home, and let's describe the PVC to learn more about it, is because this particular persistent volume gets mounted to the Jenkins pod, which in turn enables Jenkins to store all configuration data, all the plugins that you have downloaded, all the artifacts, all the system settings that you have configured in this persistent volume. So even if you lose the pod or if you lose the persistent volume, PX backup can help you recover to your original state without needing to reconfigure everything again in Jenkins. So let's verify that our Jenkins PVC is mounted to the correct location inside our pod, and it's mapped to the correct PVC or persistent volume claim. Next, let's navigate to the UI for our Jenkins installation. Here you can see that we have configured a simple system level message that shows up at the top, Jenkins deployment for EFS backup demo. We have a couple of demo artifacts, a pipeline, and a freestyle project. And then if we click on manage Jenkins, we can see that we have installed a bunch of plugins that are needed for our CI/CD pipelines. This is where we have downloaded and configured the Kubernetes plugin, the Git plugin, the Maven plugin, different Kubernetes CLI and credential plugins. So there has been work gone into configuring this particular Jenkins installation, and we would not want to lose it in case of a cluster failure or a node failure or a persistent volume failure. So that's where PX backup can help. So let's navigate to the PX backup user interface and look at a couple of settings before we configure the backup. Let's look at cloud settings. So this is where we have configured and attached our AWS account as a cloud account, and we have configured an S3 bucket as a backup location called PX backup 21. So once we have these things configured, we can navigate to the cluster. Here we have the primary cluster, which is the EFS cluster, and a secondary cluster for restore, which is the Jenkins restore cluster. On the EFS cluster, if you click on it, you will see a list of all the different namespaces that are configured on the cluster. Our resources are deployed in the Jenkins EFS demo namespace, and you can basically select that namespace, hit backup, and specify or enter a name for the backup job, select a backup location, so which is the S3 bucket that we configured earlier. We can take an ad hoc or on-demand backup, or we can schedule this backup on a particular schedule. We'll do an on-demand backup for this demo purposes. So at this point, PX backup is talking to your EKS cluster and taking an end-to-end backup for not just your EFS backed persistent volume, but also all the Kubernetes objects like deployments and replica sets and pods and service objects, and storing it in the S3 repository. Once the backup is successful, you can go ahead and restore from the same backup snapshot on the same cluster in the same or different namespace, or you can choose to restore it to a different cluster in a different namespace altogether. So you can also use the backup activity timeline to look at the status of your backup jobs for the last 24 hours to last 30 days. Now we see that our backup has successfully completed. So at this point, what we'll do is we'll navigate back to our CLI. Let's confirm that all the different objects that we wanted to back up have been backed up. So deployment and persistent volume claim and a service object. On the CLI, we'll basically delete our Jenkins installation completely. So we deployed Jenkins using a simple YAML file called jenkins deploy.yaml. This had the deployment, persistent volume claim, and service objects. We'll delete everything that was configured as part of the namespace for our Jenkins application. And then we'll try to restore the application to a different namespace. So once the application is successfully deleted, we'll navigate back to the PX backup user interface and perform a restore operation. It takes a while because we have to get rid of the persistent volume and clear any data. So now that everything is deleted, let's just verify that we don't have any remaining objects. So if I do a get all in the Jenkins EFS demo namespace, we don't see anything. If I do a kubectl get PVC in the Jenkins EFS demo namespace, again, there are no PVCs as well. So everything is successfully deleted, and this basically simulates a failure event. So now let's navigate to our backup snapshot and hit on restore. Here we can give a simple name for the restore. So we'll just use restore, new namespace, but the same EFS cluster. So we'll select the EFS cluster. We'll do a custom restore because we want to restore it to a different namespace. So you can map a different namespace, you can map a different storage class, and you can select all resources, or you can select a specific combination to perform the restore operation. Once you hit restore, PX backup again talks to your EKS cluster, which is backed by EFS, and starts provisioning resources. So it starts by copying data into a persistent volume. So it provisions a brand new persistent volume backed by EFS and starts copying data over to that persistent volume. Once the volume is successfully restored, it will start provisioning your Kubernetes objects, so your deployment and service objects, and again the Kubernetes pod that's spun up as part of Jenkins. Once the restore is successfully done, you can see that it restored one volume and two resources. If you look at more details, you can find the service and the deployment object, and then volumes were restored as well. Let's go back to the CLI and fetch the load balancer in IP for the new Jenkins installation. So if everything worked correctly, we should be able to log into Jenkins using our own old user credentials and look at the same system message, the same set of plugins that were installed. So again, my Jenkins installation was basically frozen in time and restored to a new namespace in the same cluster. So we see our artifacts there, we see the system level message, and if I navigate to manage Jenkins and navigate to the plugin section, I can see all the same plugins that were pre-configured on my original Jenkins installation. That's how easy it is to use PX backup to protect applications running on an EKS cluster backed by an EFS volume. That's it for this demo. Thanks for watching.